Hello everyone and welcome back to another video. In today's video we'll be going over shifted conics, and so we're going to be tackling this problem that we have on the left hand side, which is x plus 2 squared over 25 plus y minus 4 squared over 4 equals 1. So the first thing we're going to go ahead and do is identify which type of conic it is. So straight away when looking at the equation, the first thing that you'll notice is that it is two fractions being added together. And the important word that I mentioned is that it is being added together. So we know that so when looking at this equation, the first two conics that we could identify it as is either an ellipse or a hyperbola, because those two equations are the only ones that are over a fraction. Versus, so we can eliminate it being a parabola and we can eliminate it being a circle, because those equations do not have them set over a fraction. Versus if we look at the equation for an ellipse and the equation for a hyperbola, we can notice that both the equation for ellipse and a hyperbola are set over fractions. So we can go ahead and eliminate parabola and circle right away and dial it down to ellipse and hyperbola. So now that we have identified it as being either an ellipse or a hyperbola, the next thing that we're going to want to establish is whether the two fractions are being added or if it's being subtracted. And here we can see that it's being added, so therefore we can state that it is an ellipse. However, the next thing that we want to identify is if it's going to be a more horizontal ellipse looking something like this, or a more vertical ellipse looking like this. The way that we identify that is by looking at the larger denominator. So here we have 25 and 4, and obviously 25 is greater than 4. So we can go ahead and determine that this ellipse is going to be a horizontal ellipse, because 25 is the bigger denominator and it's under x. So now that we've established that it's going to be a horizontal ellipse, the next thing that we're going to go ahead and do is identify the center. So the center for our ellipse is going to be our HK. So in this example, it's going to be 2 and it's going to be 4. So when identifying that, we're going to know it's going to go ahead and be -2, 4. And you just take the opposite of whatever. If it's positive, then it's going to be negative, and if it's negative, it's going to be positive. So here it was a +2, then the center is going to be -2, and here we have a -4, so the center is going to be 4. So it's going to be -2, 4. So let's go ahead and plot that on our little graph over here. So we have -2, and then 1, 2, 3, 4, somewhere around there. So the next thing that we're going to go ahead and identify is going to be our A value and our B value. So our A value is going to be 25 and our B value is going to be 4. So the standard equation for a hyperbola is going to be x plus h squared over a squared minus y minus k squared over b squared equals 1. Or you can flip them, basing it on, if it's a vertical ellipse, then the y is going to be y minus k squared minus x plus h squared. Or sorry, excuse me, this is an x minus h squared here. Like that. So as I was saying, it could also be y minus k squared over a squared minus x minus h squared over b squared equals 1. So the time that we would use this second bottom one is if it was the denominator under y was larger, but because the 25 is the larger denominator in this equation, we're going to use the top equation. So knowing that, when looking for our a and our b, we can see that in the original equation, the a squared is being, or the a is being squared. So knowing that, when looking at 25, our a, just one singular a, is going to be 5. So applying that with the same mindset for b, 4, the square root of 4 is just 2. So we're going to treat a like our major axis, and we're going to treat be like our minor axes. So knowing that, our major axis is going to be along the x-axis because 25 is the largest denominator under x, and so therefore our major axes will be the x-axis or the horizontal axes. So knowing that, we can go right 5 and left 5. So I'm going to add some more points here. Oh, sorry, that is the wrong color. So we're going to go ahead and move from this center point over 5. So we have 1, 2, 3, 4, 5. And we're going to move left 5 as well. So if we're at -2 here, we're going to go 1, 2, 3, 4, 5 over. So now the next thing that we're going to do is we're going to look at our B value. And our B value is going to tell us how much to go on our minor axes. So in this case, it's going to be along the y-axis. So we're going to go down to 1, 2, and we're going to go up to 1, 2. So now when we draw our ellipse, it's going to look something like this. And the final step that we're going to do is finding our foci. And the equation for that is going to be c squared is equal to a squared minus b squared. So knowing that, we're going to do c squared is equal to 25, again, right from our original equation, minus 4. And so therefore, c squared is going to be equal to 21. And then c is going to be square rooted, so square root of 21. And so therefore, the way that we can determine, if we look at the square root of 21, we know that, let's say 5, so the square root of 25 is the next one since it's going to be 5. So the square root of 21 has to be less than 5, but the next one over is going to be square root of 16, which is 4, but it is going to be greater than 4. So rad 21 is in between 4 and 5. So knowing that, our foci is also always along our major axes. So we're going to go from our center again. Everything revolves around the center, and we're going to stop in between 4 and 5. So we're going to go 1, 2, 3, 4, 5. So it's going to be right before our vertice right there and right before our vertice right there. So that is how you find the foci. So if we were to write out the foci equation, it would be -2 plus or minus the square root of 21, 4. And that is how you graph this ellipse with this certain equation. I hope that helps. Thank you.